here is the video for lesson 7.4, exponential functions. So we are going to talk about how our equations that have exponents in them look. And so the best way that we can graph these functions is to create a value table that has your x's, and you can just pick any random numbers. I went through and helped set us up with the first table and the rest of them for the notes, but then for the homework, you're going to be the one to come up with the table yourself. I recommend using these same numbers because you get a little bit of the negative, you have a 0, and then you have some positive numbers. So it gives you a wide range of negatives, positives, and 0 to help you make your line. And so linear functions, which we had been talking about up until this point, created straight lines. We talked about linear functions as like y equals mx plus b, things like that. Different equations that are similar to slope-intercept. We talked about standard. We talked about point slope. For exponential functions, there's really only one set way that we can see our equation, and that is something like y equals a to the b power. Sometimes we can get like a number in front of the a. If we want to kind of stretch out the function, we can also have a number being added or subtracted either in front or behind it, things like that. But it's really just a function that has an exponent. And so it's going to be a curved line rather than a straight line. So let's come up with some values. So for this function right here, we have y equals 2 to the x power. The best way to do this is to just type in your calculator 2 to the negative second power. So what we're doing is we're taking our x values, plugging them in for x into our equation, and finding the output y. So 2 to the negative second power is 0.25. 2 to the negative first power is 0.5. 2 to the 0 power is 1. That was our 0 rule. 2 to the first power is 2. 2 to the second power is 4. And so you can double check yourself with your calculator there. And so now what we're going to do is we're going to graph these on our graph right here. So my first point, again, I did this so that way I have an ordered pair, an x value and a y value, negative 2.25. So I'm going to go over 2, up 0.25, which is about like 1/4 of the way between 0 and 1. It doesn't have to be perfect, it's kind of a somewhere there in the middle. I have negative 1/2. So I'm going over 1, up 1/2. I have 0, 1, 1, 2, and 2, 4. So you can see that there's going to be a nice curve here. And so when you draw this curve, you want to make sure to extend your line through them and create arrows on the end here, showing that this is an infinite line that stretches out forever. Okay, so let's talk about some qualities of this line, some characteristics. So the first is that this is increasing because my values start to get bigger and bigger and bigger, and you can see that my line is extending up. It is going to increase. My y-intercept is 1. Remember, your y-intercept is just where your line is crossing the y-axis. They're at 1. So the next thing is we're going to talk about the domain, and if you need a refresher on that, that is all of your, let me rewrite this, all possible x values. And so we're looking, what could x be? And in this case, x can be any number, so all reals. Because our x, which is this axis right here, you can see that this line extends out forever and ever and ever and goes this way forever and ever and ever. So we're capturing all x values here. Then that makes our range all possible y values, but this one is a little bit different because notice that I'm looking at my y-axis right here, and you can see that there's a point in which that it starts to stop, it starts to level off. So you can see that this line is never going below this part right here, and so we are going to say that y can only be greater than 0. See, my line does not go anywhere, it does not touch any of these points down here. It stops, we stay in the positive region. So I'm going to say that all of my y values just have to be greater than 0. Okay, and then this word right here is asymptote, and we are not going to talk about it, so you can just kind of cross those out. That's more of an Algebra 2 concept, and you will eventually get to that in that class. So we'll kind of skip that for now. Okay, So let's keep going. So kind of the way that we go through these, and I have quite a few examples that I'm going to be doing. So this video is going to be a little bit longer, but if you feel like you're getting the hang of it, then you feel free to work ahead, kind of check with me as I go, skip around, but you're doing the same thing every time. So I'll go through that. First, you're filling out your points. So let's do that. So when I type in my fraction here into my calculator, you want to make sure to put it in parentheses. So if it helps me to write it in here, you want to type it in your parentheses, then you're going to take it to the negative second power. So 1/2 to the negative second power is 4. Negative, or 1/2 to the negative first power is 2. 1/2 to the 0th power is 1. 1/2 to the, if my calculator will work, 1/2 to the positive 1 power is just 1/2 or 0.5. And then finally 1/2 to the second power is 0.25. Okay, then now I'm just going to fill that out again. So I'm graphing my points. I'm at -2, 4, -1, 2, 0, 1, 1/2, 2, 0.25, about 1/4. So I'm going to create my line again. Perfect. Extending that out. And it looks something like this. Notice how this is the exact opposite of what we did above. And that is because our numerator and denominator are flipped. Therefore, I'm going to have a flipped kind of line function here. Okay, this time we have a decreasing line because my values start to get smaller and smaller and smaller. My y-intercept is still 1. My domain is still going to be all reals because even though it's just in opposite directions, my line still extends out forever across the y-axis. Or across the x-axis, sorry. And then our range, still going to be y is greater than 0 because even though, again, we're flipped, it still stays in the positive, still stays, your y's are only up here, right? My graph doesn't go anywhere below 0. Okay, so then the last one, I'm just going to type in 3 to the negative second power, which gives me 0.11, or you might be getting fractions, like you might see 1/9. 3 to the negative first power, 0.33, or 1/3. 3 to the 0th power is 1. 3 to the first power is 3. 3 squared is 9. So I'm at -2.11, and if you're thinking, what in the world, just like make a point like right there. It almost is on top of the y equals 0 line, or in other words, the x-axis, but it's not quite there yet. Then at -1, I'm like 0.33, so about 1/3 of the way up. 0, 1, 1, 3, 2, 9. Okay, so I'm going to create my line here. Let me redo that because you don't want your line to like be intersecting the x-axis here, because technically like your 0.11 is not 0, it's still greater than 0, right? 1/9.11 is greater than 0. So I don't know how to get rid of this. What is that? Okay, well, I don't know. There we go. Okay, so I am increasing. I'm back to increasing. My values are getting bigger. My y-intercept is still 1. We'll talk about that in a second. My domain is still all reals. So if you're at the point where you're like, okay, I think my domain is going to be all reals, you're right. Our line is always extending out forever across the x-axis. The range, still y is greater than 0. My line is staying in that positive region. Y is greater than 0. Okay, so let's talk about a couple things. First, our y-intercept being 1 every single time. Well, that makes sense because if I'm taking anything to the 0th power, which is what my y-intercept is, we're saying when your x is 0, what is your y value, right? When my x is 0, what is that y value here? And so anything to the 0th power is 1. So that's going to make sense that our y-intercept is 1. Also, let's talk about how this is kind of a stretched out version of this one right here. As we start to increase the whole number in front of our exponent, we start to get a bigger stretched out line, okay? Now let's move on to the back. These are a little bit different only because we have something else to consider, and that is a -1 after our exponential function. So this is what I was talking about earlier, where we might have a 1 being added or subtracted. On the homework, you might see a number in front multiplying. Same idea, you can type it into the calculator the same way. So there's two things that you can do. The first thing is you can realize, hey, I already know what 2 to the x power, what those values were in my function. And so I can just copy those down, except I need to then subtract 1 after it, right? Because you're still doing 2 to the x, which if I plug in -2, that gives me 0.25. But then remember, our function down there was -1. So what we would type in is 0.25 minus 1, which gives me -0.75 right here. So we're saying 0.25 minus 1, -0.75. Or you can completely type it in again. That's fine. Make sure when you type it in, though, I would put this in parentheses and like make that its own thing and then type in your -1. Just to like make sure your calculator isn't accidentally doing something weird. Okay, so then I'm going to go ahead and fill the rest of these out. So we have 0.5 minus 1, which is -0.5, 0 minus 1, which is -1, 2 minus 1, which is 1. Oh, wait, no, sorry. This one right here, it should be 1 minus 1, which is 0. 2 minus 1 is 1. 4 minus 1 is 3. Okay, so you should be getting those numbers. If you are having issues with this, please let me know. Okay, so then I'm going to just graph like I've been doing this whole time. So I have -2 down 0.75. So like we're almost hitting 1, but we're not there yet. We're about, just a little bit off. Then I have -1, -0.5. So that's halfway between 0 and -1. I have 0, 0, the origin. I have 1, 1, and 2, 3. So this is going to be my line here. Okay, so let's talk about some characteristics of this line. We're still increasing, so that isn't changing. This -1 isn't changing whether or not I'm increasing. What that -1 is doing, it's actually shifting your line down. So before we had 2 to the x, see how it was the same line, same distance apart, but you were crossing your y-axis at 1. Well, we shifted it down 1, we subtracted 1, so now my y-intercept is 0. So that's what we're doing there. We're just shifting it up and down. My domain is still all reals, but my range changes. And so see how I can now dip below the x equals, or the x-axis here. And the line now is right here where my line isn't crossing. So I'm going to say that y has to be greater than -1. All my values stay above this -1 line. So that's going to be my range. Y is greater than -1. I just shifted it down 1, therefore my range also gets shifted down. And then the last one, same idea. I'm going to use the 1/2 x, and then I'm going to add 3. So the numbers that I got to whenever I typed in 1/2 x and I got all those values, I'm just going to add 3 to them. That's going to be my new numbers. Or you can completely type it in again. It's fine either way. So I had 4 plus 3. So again, I'm getting this number because I'm looking up at here and seeing what were my table of values. I already typed that in. I already know 1/2 to the x power. But now I'm just adding 3. And so that gives me 7. 2 plus 3 is 5. 1 plus 3 is 4. 0.5 plus 3 is 3.5. And then I have 0.25 plus 3, which is 3.25. Okay, so then now I'm just going to plug everything in. So I have -2 up 1, 2, 3, 7 right here. -1, 5, 0, 4, 1, 3.5, 2, 3.25. Again, they don't have to be perfect, just kind of the general location. And make your line, make your arrows, and now we can start talking about it. So this line is back to decreasing. Again, just because I'm adding 3 doesn't change what I'm doing, it's shifting it up. So, oh wait, I messed up here. I was about to say, this looks really weird. This should be my 4, this should be my 3.5, this should be my 3.25. Yeah, there we go. Let's try that again. Okay, so now this looks better. It looked weird for a second. So my y-intercept is 4 because, again, think back to our discussion where we said our y-intercept of these just base functions are going to be 1, but it's telling me to add 3 to that, so it would make sense I'm shifting up my line 3 to land me as my y-intercept now being 4. Domain still all reals, and the range is now y has to be greater than 3. So my line is not going and dipping below 3 here. It has to stay greater than 3. And then that's it. We're not going to do this because this isn't part of the homework. Just the graphing is. So if you have any questions on that, let me know.